Monoquadratic polynomials p of x and q of x have the property that p of q of x has zeros at x equals minus 23, minus 21, minus 17, and minus 15, while q of p of x has zeros at minus 59, minus 57, minus 51, and minus 49. What is the sum of the minimum values of p of x and q of x? So how can we get started on this problem? Well, we see that p of q of x has zeros at x equals minus 23, minus 21, minus 17, and minus 15. So we can write that p of q of minus 23 equals p of q of minus 21 equals p of q of minus 17 equals p of q of minus 15 equals 0. So we see that q of minus 23, q of minus 21, q of minus 17, and q of minus 15 are all roots of p of x, because that's the only way you can apply p and then get 0. So we have q of minus 23, q of minus 21, q of minus 17, and q of minus 15 are roots of p of x. And similarly, for q of p of x, we have that p of minus 59, p of minus 57, p of minus 51, and p of minus 49 are all roots of q of x. Now I'm going to draw the graphs of p of x and q of x to see what we have here. This is p of x, and that's q of x. They're monic quadratic polynomials. Monic means they have a leading coefficient of 1. Mono means 1. So it's like x squared plus ax plus b or something. We can label p of x, and this is q of x. Now we see that q of minus 23, q of minus 21, q of minus 17, and q of minus 15 are roots of p of x. But p of x only has two roots since it's a quadratic polynomial. We have to draw the horizontal lines where y is equal to each root of p of x. And then we have to graph the points where those horizontal lines intersect the graph of q of x. Let's do that in a different color. This is the lower root of p of x, and this is the higher root of p of x. We can see that they intersect the graph of q of x at 4 different points. That's the only way you can apply p of q of x and get 0. When q of x is equal to some root of p of x. And these horizontal lines represent those two roots. So we see that those points are equal to minus 23, minus 21, minus 17, and minus 15 for x. We notice that the average of minus 21 and minus 17 is equal to the average of minus 23 and minus 15. Both averages are equal to minus 19, and that's going to have to equal the axis of symmetry of the parabola q of x. So let's draw that. That needs to be located at x equals minus 19. And similarly, both roots of q of x are also equidistant from x equals minus 19. This is y equals 0. And it intersects q of x at two values of x, which I'll call minus 19 minus q and minus 19 plus q. I use q because the polynomial is known as q of x. So now we can write an equation for q of x using the symmetry-based approach. We can call it q of x equals x plus 19 plus q from the first root at minus 19 minus q times x plus 19 minus q. It needs to have leading coefficient of 1. So it's x plus 19 plus q times x plus 19 minus q, and that's equal to x plus 19 squared minus q squared. So now what do? Well, we see that q of p of x has zeros at minus 59, minus 57, minus 51, and minus 49. we can graph those on P of x. We need the horizontal lines y equals the 2 roots of q of x. Those are x equals minus 19 minus q for the lower one, and x equals minus 19 plus q for the higher one. And the 4 points where these two lines intersect the graph of P of x have x coordinates minus 59, minus 57, minus 51, and minus 49. So the axis of symmetry, if we follow the symmetry-based approach once again, we get that the average of both the pairs minus 59, minus 49, and minus 57, minus 51, the average of both of them is equal to minus 54. So this line has equation x equals minus 54. So the 2 roots of P of x can be represented as minus 54 minus p and minus 54 plus p. And those were the 2 roots in question when we draw those 2 lines on q of x. When we drew them here, we didn't know what they were, but now we do. These horizontal lines have equations y equals, this should be y equals, not x. These have equations y equals minus 54 minus p and y equals minus 54 plus p. So now we can get the equations for P of x. It's equal to x plus 54 plus p times x plus 54 minus p, which is equal to x plus 54 squared minus p squared. So now we have the equations of both P of x and Q of x. Let's start plugging in some values for P of x and Q of x. So if we plug either minus 57 or minus 51 into the equation of P of x, we'll get that P of minus 57 equals P of minus 51 is equal to minus 51 plus 54 squared, which is 3 squared. P of minus 57 would be negative 3 squared, but that's the same thing as 3 squared. They're both equal to 9 minus p squared. And similarly, P of minus 59 equals P of minus 49 equals 5 squared minus p squared. P of minus 57 and P of minus 51 lie on y equals minus 19 minus q. And P of minus 59, P of minus 49, they lie on y equals 19 plus q, minus 19 plus q. So it turns out we can subtract these two equations and end up with the value of q. We have 5 squared minus 3 squared equals 2 times q. But this is just 5 minus 3 times 5 plus 3 equals 2q. 5 minus 3 is equal to 2, so 5 plus 3 is equal to q. We have q equals 8. Now we can sub the value of q equals 8 into the equation of q of x. We have that this is equal to x plus 19 squared minus 8 squared, which is 64. And now we can use x equals minus 17 and minus 15 to get the q of x values of those 2 points. Those should be equal to minus 54 minus p and minus 54 plus p, respectively. So we have q of minus 17 or q of minus 21. Either way, it's equal to 2 squared minus q squared. And that's equal to 2 squared minus 64, or 4 minus 64, negative 60. That's equal to minus 54 minus p. And that's all we need to find the value of p. We know that p is equal to 6. So q is equal to 8 and p is equal to 6. We want to find the sum of the minimum values of P of x and Q of x. But this is just minus p squared minus q squared. The least x plus 54 squared can get is 0. The least anything squared can get is 0. No real number, when squared, will equal anything less than 0. So this is just minus p squared minus q squared, which is just minus 8 squared plus 6 squared. And that's equal to minus 36 plus 64, which is minus 100. Going back to our answer choices, we see that minus 100 is equal to answer choice A, and so we are done. Thank you all for watching my YouTube video. If you enjoyed, please leave a like down below, and please follow my channel if you would like to see more videos. Help us get to 200 followers before the AMC 12B on Tuesday, November 14, and to 400 followers before the Amy 1 on January 31.